Hello students, welcome to Anne's classes. Let's do triangles, chapter 9 and introduction. Let's go through some basic concepts of triangles. A plane figure bounded by three straight line segments is called a triangle, and every triangle has three sides and three angles. Now we have a triangle here. Now this is A, B and C, and as we just read, every triangle has three sides, AB, BC and AC, and three angles, angle A, angle B and angle C. Now let's study the relation between sides and angles of a triangle. Let's take the first case where if all sides of a triangle are equal, all its angles are also equal. So what are the three sides? That is, now let's take triangle in triangle ABC. Let's take the three sides. What are the three sides? AB, BC and AC. Now if AB is equal to BC and BC is equal to AC, that means all three sides are equal. This implies that even the angles will be equal. That is, angle A will be equal to angle B and this will be equal to angle C. Okay, so if all sides are equal, their angles also will be equal. Conversely, if all angles of a triangle are equal, all its sides also will be equal. So this is the first case. Now in the second case, it's just a converse of the previous one. That is, if the angles are equal, if angle A is equal to angle B and is equal to angle C, this implies that the sides also are equal. That means AB will be equal to BC and this will be equal to AC. So this is the first relation between sides and angles. When all sides are equal, all the angles are also equal. Now the second relation is if any two sides of a triangle are equal, the angles opposite to them are also equal. So here let's take triangle ABC in which AB is equal to AC. So in triangle ABC, side AB is equal to side AC. So here it says if any two sides are equal, then the angles opposite to them are also equal. This is true conversely also. This time, if any two angles of a triangle are equal, the sides opposite to them are also equal. That is, if I take angle B and I say it's equal to angle C, then it implies that the side that is opposite. What is the side that is opposite to angle B? AC. And what is the side that's opposite to angle C? AB. That means AC, side AC is equal to side AB. So this point is important. If any two sides of a triangle are equal, the angles opposite to them are also equal. Conversely, also it is true. Now the third kind is if all the sides of a triangle are of different lengths, its angles are also of different measures in such a way that the greater side has the greater angle opposite to it. So this point you have to understand. So let's have a triangle. We have our triangle here. Let's name this. This is triangle ABC. Now in this triangle, that is in triangle ABC, the sides here it says all the sides are of different lengths. That means AB is not equal to BC and this is not equal to AC. So what does it say? If that is so, then the angles also are of different measures. So this implies that the angles, that is angle A, is not equal to angle B. This is not equal to angle C. So this is the first point. If the sides are of different lengths, the angles also are different measures. And in such a way that the greater side, now if you look at this figure, the greater side is AC. The greater side has a greater angle opposite it. That means AC is the greater side. The greater angle is angle B. So here we can say side AC is greater than side BC which is greater than side AB. So we're talking about sides here. Now let's talk about angles. What is opposite side AC? The angle opposite side AC is angle B. So we can say angle B is greater than angle. Now what is opposite BC? A. So angle A, which is greater than angle C. Now this is true conversely also. So conversely, if all the angles of a triangle are of different measures, then its sides are also of different lengths, in such a way that the greater angle has the greater side opposite to it. It's just the converse. Here we said the greater side has the greater angle. This is also true. The greater angle has the greater side opposite to it. So if all the angles are of different measures, so let's write that first. So in this case, all the angles are different. So we are talking about angles. That is, angle A is not equal to angle B. This is not equal to angle C. Then in that case, the sides also are of different lengths. That means this implies that side AB is not equal to side BC, which is not equal to side AC. Then what does the other part say? It says the greater angle. Now, which is the greater angle? Angle B and angle C are the three angles. Now, if I use the same triangle, that is in triangle ABC, then angle B is the greater angle. Angle B will be greater than angle A, which is greater than angle C, according to the given figure. Then here what does it say? The greater angle has the greater side opposite to it. So the greater angle is B, that is here, which is the greater side opposite AC. So we can say AC is greater than, now here we have angle A. What is opposite that? BC, greater than BC, which is greater than, now angle C is here, opposite that is AB, greater than AB. Now let's go through some important terms. The first one is the median. The median of a triangle corresponding to any side is the line joining the midpoint of that side with the opposite vertex. So if you take any side, the line that joins the midpoint of that side with the opposite vertex. So let's take a triangle. So we have a triangle here, triangle ABC. Now, if we are talking about line BC, the midpoint of this line is the point in the middle which divides this into two equal halves, and from that point to the side with the opposite vertex. So from here to the opposite vertex, this is the side, the midpoint to the opposite vertex. What you draw like this is called the median. So this is the midpoint of BC, dividing this into two equal parts. So BC has been divided by this point in the middle by into two equal parts, and this line from D to the opposite vertex, that is AD now, this is called the median of this triangle ABC. So AD is the median corresponding to side BC. So we have taken BC. Let's take another one. So in this case, in triangle ABC, this time let's take side AC. That means the midpoint. You have to get the midpoint, and from the midpoint, the opposite vertex will be B. So the vertex here is B. So if you have a line from the midpoint to B, that is called the median of the line AC. So here we have a midpoint, and let's name that midpoint as E. So this has now divided this into two equal parts. That means AE will be equal to CE. These parts are equal, so this is the midpoint, and the line joining the midpoint of this side with the opposite vertex B here is called the median of this line. That means in this case, BE is the median corresponding to side AC. Let's take one more triangle. So here again, we have triangle ABC, and let's take the midpoint of line AB. So it will be in the middle. So the line that you draw from the midpoint to the opposite vertex, which is C, that will be the median. So we have a median here, and let's name this midpoint as point F. And this has divided, the midpoint F has divided the line AB into two equal parts. So we have AF and BF. So it's divided into two equal parts, and in this case FC or CF is the median corresponding to side AB. So now I hope all of you understood what the median is. It's the line drawn from the midpoint of any side to its opposite vertex. Now the next one, a triangle has three medians and all three medians are concurrent. That means they intersect each other at one point only. So as you saw, triangle has three medians. We drew one for each triangle, but when you draw all three together, you have three medians in a triangle and they're all concurrent. They all intersect, they meet at a particular point. So here we have a triangle, let's name it. So we have triangle ABC. Now here we have a median from A. Let's name this midpoint as D. So AD is the median of BC, and then this is dividing BC into two equal parts. This midpoint D has divided BC into two equal parts. Now we have the next one, that is we have a median starting from the midpoint E. This is midpoint E and this is a midpoint of the line or of the side AC. It's divided AC into two equal parts. So these are the two equal parts and it has joined the opposite vertex, which is B. So EB or BE is the median of AC. Now we have one more, isn't it? Let's name this midpoint as F. Now this midpoint F has divided the line AB into two equal parts. So we have one part here and one part, both these parts are equal in measurement. And FC or CF is the median of AB. Now, as you can see, all three medians intersect at a particular point. The point of intersection of the medians is called the centroid of the triangle. So this is called the centroid of the triangle. So in the figure, O is the centroid. So let's name this as O. So the point that where all meet, all three medians, they are meeting at a particular point here, this point in red here. So that is the centroid of triangle ABC. The centroid of triangle divides each median in the ratio 2:1. That is, let's take this first median AD. Now look at AO and OD. So this is twice this part. It's always like that. The centroid will divide each median in that ratio. That means if I say AD, let's write down AD is AO is to OD is in the ratio 2:1. AO will be 2 and OD is 1. So AO is to OD is 2:1. Similarly, look at BO and OE. BO is to OE will also be in the ratio 2:1. Then we have CO. Watch the figure carefully. CO is to OF and that is in the ratio 2:1. So that means the point of intersection of the medians is the centroid and this is the point. O is the centroid and the centroid divides each median in the ratio 2:1 as we can see here. The second concept is altitude. An altitude of a triangle corresponding to any side is the length of the perpendicular drawn from the opposite vertex to that side. Okay, so let's go through this carefully. Now suppose we have a triangle, let's name it ABC. This is triangle ABC. Now what does this statement say? It says the altitude corresponding to any side. That means let's take side AC. What will the altitude be? It is the length of the perpendicular drawn from the opposite vertex. That is, this is the opposite vertex. If I draw perpendicular from there to line BC, side BC, that will be the altitude. And what is a perpendicular? Perpendicular line is one that touches another line at 90 degrees. The angle is very important. So if I have to draw one corresponding to side BC, this is how we'll get our perpendicular. This is from A and let's name this point where it touches line BC. Let's name it as D. Remember, this is not the midpoint. When you draw the same thing from a midpoint to the opposite vertex, it is called a median. But here, when you draw a perpendicular from the opposite vertex, it's called the altitude. So in this case, AD is the altitude of side BC. Remember, it touches the line at 90 degrees. So let's draw that. So we have 90 degrees on both sides. So here you have 90 degrees. Here also at 90 degrees. Only then you know that this is the perpendicular. So AD is the altitude corresponding to side BC. Let's take another triangle. So here we have again triangle ABC. And this time let's take side AB. So here we have side AB. The opposite vertex is C. From here we're going to draw a line touching AB. Remember, it should be a perpendicular line. We're not looking at the midpoint. We're looking at a perpendicular line. That means it must touch this line side AB at right angles. So we have a line drawn. Can you see? This is not the midpoint. So let's name this as CF. So we have this line CF. This is the altitude of side AB. Again, here also, since it's perpendicular, we have 90 degrees on both sides. So let's write that. CF is the altitude corresponding to side AB. Next, we have another triangle ABC. So here we took one side. Here we took BC, here we took AB, now we have AC left. Now what is the altitude to side AC? From the opposite vertex, that is B, you have to draw a perpendicular. That means touching this line at 90 degrees. Let's draw that. So here we have the line drawn. Let's name this as E. So this point here is E. That means BE is the altitude of side AC. Again 90 degrees because they are perpendicular. It's a perpendicular line touching AC at 90 degrees. So BE in this case is the altitude corresponding to side AC. Now a triangle has three altitudes and all three altitudes are always concurrent. That means they intersect each other at one point only. Now let's draw a triangle. Let's name it ABC and let's draw all three altitudes on the same triangle. So let's draw the first one. So we have the first one here and this is corresponding to the side BC. So this is D. So let's name this D. So we have the first altitude AD corresponding to side BC. Next one we have altitude. Now let's name this as C. The one between C and A as E. So now the altitude BE is the one corresponding to side AC. Then we have the last one here. So here corresponding to side AB we have FC or CF. Now they all intersect at one point only. So can you see they're all intersecting at one point? Let's call that point O. The point of intersection that is here, we'll call that point O. The point of intersection of the altitude is called the orthocenter. Remember, this is called the orthocenter of the triangle. And in the figure, O is the orthocenter of triangle ABC. So I hope you know the difference between the altitudes and the medians. Now figures are said to be congruent when they have the same size and shape, and if one figure is placed over the other, they will coincide exactly. So they should have the same size and shape, and when they're placed one on top of the other, they must coincide exactly. Now here we have two shapes, we have two lines. Now let's see what we mean. Now look at these two shapes, triangles. They are exactly the same size and the same shape. Now if I place this one on top of this triangle, will they coincide exactly? Let's see. Okay, as you can see, they have coincided exactly. That means those two triangles are congruent shapes or congruent triangles. Now let's take another example. Look at these two shapes. They are the same size, same shape. Now let's see if they coincide when they are placed over each other. So let's do this. So here also, as you can see, they are coinciding exactly. That means those two shapes are congruent. Now here we have two lines, and let's see if these two lines, when they're placed one on top of the other, they will coincide exactly. Yes, as you can see, they have also coincided. That means they are congruent lines. So this is the meaning of congruency. They have the same size, same shape, and when they're placed over the other, they will coincide exactly. So let's study about congruent triangles. This exercise is on congruent triangles. So here we have two triangles. Now they are exactly the same size. Now as you can see, they have three sides. Now there is AB, BC and CA for this triangle. For this triangle, DE, EF and FD. Now there are strokes here. What do these strokes mean? There is one stroke here, and look at the other triangle. There's one stroke for this side. That means this side is equal to this side. That means AB is equal to DE. Now here there are two strokes and here there are two strokes. That means BC is equal to EF. Here we have 3 and 3. That means AC is equal to DF. So we are talking about the sides. So these three sides are equal to each other. Now here we have the symbol for angles. So here there's one curve to show that this angle and this angle with that one curve are equal. That means angle A is equal to angle D. Now look at the two curves here, angle B and two curves for angle E. Angle B is equal to angle E. Here we can see three curves. That means angle C is equal to angle F. So right now they are the same shape, they are the same size. Now do they coincide? If they coincide, that means when you place one triangle on top of the other, if they are exactly coinciding with each other, then they are called congruent triangles. So let's see that. Yes, can you see that? They are coinciding exactly. You can see the vertices also. They have coincided exactly. So triangle ABC is congruent to triangle DEF. So we had two triangles. Now they're the same shape, same size, and when they're placed one on top of the other, they are coinciding exactly. So you can say triangle ABC is congruent to triangle DEF. Now here, these are the sides that are equal. AB is equal to DE, BC is equal to EF, and AC is equal to DF as we saw. Now, this is another way of showing. This is the symbol for congruency. So instead of using the words congruent, you just have to put this symbol. So this shows that triangle ABC is congruent to triangle DEF. Now there are conditions of congruency. When do you say that two triangles are congruent? Now there are 5 conditions. So let's look at the first condition. So in the first condition, we are looking only at the sides of a triangle. That is, if 3 sides of one triangle are equal to 3 sides of the other triangle, each to each, as we saw in the first example, then the two triangles are said to be congruent. So this is the first condition where we're only talking about sides. So here we have two triangles A, B, C and D, E, F. Now we are talking about the sides, so the 3 sides are there. If these 3 sides are equal to these 3 sides, that means we say that two triangles are congruent. So here we have one stroke, one stroke. Then we have 2 and 2, 3 and 3. So this condition is known as side, 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 or SSS. For you just take the first letter of each word. So the first condition of congruency is two triangles are said to be congruent based on SSS. That means 3 sides are equal. As you can see, AB is equal to DE, BC is equal to EF, and AC is equal to DF. The 3 sides are equal. Now, because it's equal, now we say that triangle ABC is congruent to triangle DEF by which condition? By SSS, or side, side, side. So you have to mention by which condition you have proved that these two triangles are congruent. So the first condition is 3 sides. Now, in congruent triangles, the corresponding angles are also equal. So when you have triangles which are congruent, even the corresponding angles like Angle A is equal to angle D, angle B is equal to angle E, and angle C is equal to angle F. Angle A and angle D are equal, angle B and angle E are equal, angle C and angle F are equal. So this is the first condition of congruency. Now, second condition of congruency. If two sides, now we're talking only about two sides and the included angle, that means the angle between these two sides. So I'll read that again. If two sides and the included angle of one triangle, if they are equal to two sides and the included angle of the other triangle, again each to each, that means coinciding, then the two triangles are said to be congruent. So again we have two triangles here. Now here we are talking about two sides and the included angle. So look at this triangle, angle ABC. There are two sides. Angle AC is 4 centimeters and angle AB is 5 centimeters. Included angle means the angle that is between the two sides, that is angle A. I'm not talking about this angle, not angle B, because the two sides are here. And included angle means the angle that comes between those two sides. So here we have two sides and an included angle. Now let's look at this triangle. Triangle DEF. Here we have two sides, 5 centimeters and 4 centimeters, and angle E, which is an included angle. If these two sides of this triangle are equal to the two sides of this angle and the included angle is equal to this included angle, then you say that the two triangles are congruent. Okay, so here let's see. This condition is now known as side, angle, side, or SAS. Side, included angle, side. So this is known as SAS, the second condition. Here AC is equal to DE. Then AB is equal to DF. And triangle BAC. BAC. We have put A in the middle because that is where the angle is. BAC is equal to triangle DEF. So two sides and one included angle. If this condition is satisfied, then what do we say? Triangle BAC is congruent to triangle DEF by SAS, by this condition. Then in this case, what are the pairs of corresponding sides? So we have AB and EF because both are 5 centimeters. Then we have AC and DE. AC, DE both are 4 centimeters. Then we have BC and DF. DF here. So they are the corresponding sides. Now what are the corresponding angles? Angle A and angle E. Then we have angle C and angle D. Then we have angle B and angle F. So these are the pairs of corresponding sides and the pairs of corresponding angles. Condition 3. Here we are talking about two angles and one included side. That should be equal to two angles and the included side of the other triangles. Then you say that they are congruent. So here we have two triangles. So as you can see, we have angle B with two curves and angle E with two curves. That means B and E are equal. Then we have angle C with one curve and angle F with one curve. That means C and F are equal. Now what do we mean by included side? Included side means the side which is between these two angles. Not the side, but this side because it's between these two angles. So we have B, C and E, F which are equal. So this is the third condition of congruency. So we say this condition is known as angle, side, angle or ASA. Angle, side, angle or ASA. So BC is equal to EF. So one side, the included side, they are equal. And angle B is equal to angle E. Angle C is equal to angle F. So we say that triangle ABC is congruent to triangle DEF by ASA. This condition, that is angle, side, angle. This is the third condition of congruency. The fourth condition of congruency is if any two angles and a side, we already had two angles and a side, but this time the side is not the included side of one triangle, if that is equal to two angles and the corresponding side of the other triangle, then the two triangles are said to be congruent. Okay, so here we have two triangles, triangles ABC and triangle DEF. Now here we are talking about two angles. Look at angle C with one stroke and angle F with one curve, both with curves. So here angle C is equal to angle F. Now look at angle B with two curves and angle E with two curves, the symbol of an angle. That means angle B is equal to angle E. Now look at this line AC. It has a single stroke and angle DF has a single stroke. That means these two lines are equal to each other. But as you can see, they are not the included side. That means they are not in between E and F. If they are in between these two angles, we call it an included side. But as you can see, they are not, these two lines are not in between the angles, so they are not the included side. But even then, if any two angles and one side is equal to the other two angles and one side of the other triangle, that means they are congruent triangles. So in this case, we say the condition is known as angle, side. So we take the first angle, the second angle and the side, or AAS. So here in this case, angle B is angle equal to angle E. Angle C is equal to angle F. AC is equal to DF. So we are talking about two angles and a side. That's why it is angle, side. So we can say triangle ABC is congruent to triangle DEF by the condition A, and S. Now we're going on to conditions of congruency, the fifth condition. So according to this, if the hypotenuse and one side of a right angle triangle, so the fifth condition is based on a right angle triangle and we are talking about the hypotenuse. If the hypotenuse and one side of a right angle triangle are equal to the hypotenuse and one side of another right angle triangle, then the two triangles are said to be congruent. So let's have a look. So here we have two triangles. Triangle ABC is a right angle triangle, as you can see at B, and it has two sides. This is the hypotenuse AC. Now here the other triangle is triangle DEF, which is right angled at E. Now here the hypotenuse has three strokes here and this is the hypotenuse because it's opposite the 90-degree triangle. So it's opposite the 90-degree angle. So AC is the hypotenuse. In this triangle, DF is the hypotenuse because it is opposite angle E. Now, if the hypotenuse of this triangle is equal to the hypotenuse of this triangle, are they equal? Yes, there are three strokes here and three strokes here. That means they're equal. And one side, so this one side, that is BC, it has two strokes, and here also the corresponding side is DE, it has two strokes. That means these two sides are equal and they are right angles. So we say that these two triangles are congruent. So how do we say the condition? This condition is known as right angle, hypotenuse, side, or RHS. Right angle, hypotenuse, side. So this condition is known as RHS. So here we have angle B is equal to angle E. You can see that here. Then BC is equal to DE and hypotenuse AC is equal to hypotenuse DF. So we have a right angle triangle. We have one side and we have the hypotenuse, which are all equal to each other. So we say that triangle ABC is congruent to triangle DEF by the condition R, H and S. That's all for now. See you in the next video.